Number 12. So again, we're going to identify the whole, the horizontal asymptote, and vertical asymptotes. But on this problem, we don't have a visual, we have the actual function. So that means we got to do a little bit of work. We got to do some simplifying and see if we can eliminate some things, if we can identify some holes. And of course, we know that we got to use our definition of vertical asymptote and horizontal asymptote. So I'm going to start with this f of x is equal to 2x minus 8 over x squared minus 4x. And I'm going to see if I can simplify it. And that will help me to determine what I need to find out. So let's see what I can do. And I noticed that for my numerator, I have a 2 GCF that I can actually factor out. That'll leave x minus 4. And on the bottom, I have an x in common that we can pull out to the side, and that'll leave x minus 4. Now notice that these two actually cancel each other out. That tells you that's where your hole would be located. So that means we have a hole. So whatever we can cancel out tells us where a hole is. So we have a hole at x equals 4. Why is it 4? Because when I set that equal to 0 and solve, that's where my hole is going to be. So for the hole, it would be this one. All right. Okay, how do we find the horizontal asymptote? Well, if you recall, we look for the degree of the numerator and the degree of the denominator, and we compare those. The degree of the numerator in this case is 1, because the degree is the highest exponent. So the degree for the numerator is equal to 1. The degree for the denominator is 2. So I'm looking at the exponent 1 here and 2 there. And remember the 3 choices for the horizontal asymptote? It says that if the numerator is less than the denominator, then your horizontal asymptote is at y equals 0. So it must be down here. And I'm going to go ahead and just put y equals 0. It's going to be our horizontal asymptote. Now for the vertical asymptote, this is the one where we have to actually do our simplifying and find out what we have here. For the vertical asymptote, we're going to just solve for x. So once I've done this work right here, and I solve for x, okay, let me stop here and go back. It says that we solve the, we're going to solve for the vertical asymptote. Keep in mind that the definition says that you set the denominator equal to 0 and you solve for x. Well, my denominator in this case is x. So if I set that equal to 0, that will be the vertical asymptote, which is this one. Problem number 13. Again, we're looking for any holes, horizontal asymptote, and vertical asymptotes. So we've got to actually simplify and see what we can come up with as far as a whole. I'm going to go ahead and simplify the top. It'll be x minus 5, x plus 5. And the bottom is going to be, well, now notice that we have a number other than 1 in front of the actual quadratic. So we have a value that's greater than 1, which means we would normally have to use the AC method, but we could also see if we can simplify that prior to having to use the AC method by checking to see if we can factor anything out. And in this case, I see there's a 2 in here, some 2's in there, some 2's in here. So what I can do is I can pull a 2 out to the front. That'll leave x squared for the first term minus 7x for the middle term plus 10 here. Now I can actually factor this if it's possible. And in this case, it's possible. This can be rewritten as, well, I've got my 2, but I can break up this quadratic that's in the parentheses as x minus, sorry, I was about to put 2, and x minus 5. Because a negative 2 times a negative 5 is a positive 10, but when I add negative 2 and negative 5, I get negative 7. And then of course this is still x plus 5, x minus 5. these will cancel. There's my whole, so I have a whole at x equals 5. So this is a whole. Now, of course, for my horizontal asymptote, I check the degree of the numerator and denominator. So the degree for the top, the highest exponent is 2. For the bottom, same thing. And think about the 3 choices. When your degrees are the same, then you have to use A over B as your horizontal asymptote. The A is the lead coefficient for the numerator, which is 1. There's a 1 here. And B is the lead coefficient for the denominator. So the horizontal asymptote is 1 over 2. Okay? Is the HA. And that'll be Y. Y equals that, which is this one. Because horizontal asymptote is going along the Y axis. And then lastly, the vertical asymptote. Remember, we take the denominator and set it equal to 0. In this case, what's left of the denominator is 2 times x minus 2. And so these are the 2 factors. Now, if I set 2 equal to 0, you know that's not true. But if I set x minus 2 equal to 0, once I solve, I'll get x is equal to 2. So this is just a line I drew. This is the VA. X equals 2, right here, VA. And that was the HA. Okay.